So what we're going to do is talk about our error. And this is one option, okay? I'll give you two options, but this is one option that you can use. So this option is where we're looking at how the temperature we recorded, the final temp, versus our gradient, or our expected value. So if we recorded a final temp of, and I gave an example of, I think 69.3 degrees Celsius, and again this is completely off the top of my head, but 69.3, so that was my final temperature. I could look at my expected temperature. How would I know what my expected temperature is? I've got an equation here, y equals 0.63x plus 10. I might make that 0.43. What could I do?
You could make an educated guess.
No educated guesses.
Something in the amount of time.
Into where?
X value.
X value. So couldn't I let, so to find my expected value y, I could let x equal 120 seconds, depending on what my value was, plus 10. And that would give me, I'll pull my calculator at that point in time and shove that in. I don't know what that would give me, but Logan, you look like you've got something in your hand that might help me out. $61.6 degrees Celsius. Okay. Now, what that has allowed me to do is talk about my expected value versus my measured value. Are we clear with that? So if I was to calculate uncertainty, what I would do is go measured value. So do you getting an idea about what we're going to do here? So we've got, I'll just go percentage error equals measured minus expected divided by expected times 100. So in this instance, yep.
When we do equal the other times, do we just do that time and that minute?
Yeah.
Do the same thing?
I would just do one, okay? I did think about doing it as a graph, so what you're saying is 30 seconds, 60 seconds.
Yeah.
Look, just pick one. Just pick your final temperature. I'm happy with that. I just really want to see evidence that you can calculate uncertainty. I don't want you to get bogged down with calculating lots of uncertainty. So just pick your final temperature and look at the linear graph, and a better experiment would do that, but I don't expect it, okay? So in this scenario, my measured is 69.3 minus 61.6 over 61.6 times 100. And then someone with a calculator would help me out.
So is y our uncertainty?
Expected value. Y is our expected value.
Okay, and then that's our percentage.
That's our percentage uncertainty.
61%.
12.5%. Very good. Okay. Now, look. I'm fabricating this a little bit, just trying to get you something to calculate some uncertainty with. Where will we find this section of our report? In our results and our calculation section. And then how would we show this? In our analysis. Cool? Oh, sorry, in our graph. How can we show it in our graph? Error bars. Clear?
Do you want us to do absolute uncertainty?
That top value here, that top value there is your absolute uncertainty. Okay? So when I was discussing the Holy Grail, I was talking about the fact that what we want to get to, and this is something that I want to highlight, all the data we've collected has got temperature versus time, and we've got heaps and heaps and heaps of data, but that can be a little bit of a double-edged sword. Lots of data is really good, but we've got to think about our research question. So what's our research question about? It's about area or thickness versus temperature. Or it was heat, but temperature, correct? So Where did I say time? I didn't, did I? So because I haven't mentioned time in my research question, I'd hope that the main graph that I'm talking about, all the stuff where I'm referencing it in my discussion, so the main focus of my graphing shouldn't be about these graphs. What should it be about? My change in temperature versus my change in thickness or area. Does that make sense? The data you've collected right now looks like this, doesn't it? You need to do something with that data. Okay, so whether that's the change in temperature, the final change in temperature, or the gradient of that line, you have to do something with that to make it so that you're comparing thickness or area and temperature.
I understand now.
Cool?
Yeah.
So you need to this is called manipulation. You need to manipulate your data to make it talk for you, to tell your story. And your story is about area or thickness and temperature. Clear?
Yes.
And with that data, what are we looking for? Starts with T, ends in Ren line. Geez, you're good. Who's your physics teacher? He needs to be paid more. Okay? So you're looking for the trend line, and with that you're comparing it to a calculation, some theory, and saying this is where it aligns with the theory, this is where it doesn't, and you're talking about why. Cool? I'm going to give you a bit of time because I've done a lot of talking and I know you need a little bit of time to let this sink in. Maybe calculate some percentage uncertainty. Then you can do some graphing, some manipulating of data. I'll just buzz around the room and give you a hand. Cool?